Did you know, if an atom were as large as a stadium, its nucleus would be the size of a pea? Welcome to the fascinating world of atomic structure. Atoms, the building blocks of matter, are composed of three types of subatomic particles: protons, neutrons, and electrons. Protons, positively charged particles, reside in the nucleus at the heart of the atom. Neutrons with no charge also huddle in the nucleus, while electrons, negatively charged, whiz around the nucleus in an area known as the electron cloud. This fundamental trio gives each atom its unique properties, determining how it will interact with other atoms and the type of element it will form. They are the reason why hydrogen is different from helium, why carbon is different from nitrogen, and why every element on the periodic table is unique. Understanding these particles is key to unravel the mysteries of the universe. First up, meet the protons, the positively charged particles residing in the nucleus of an atom. These little powerhouses are more than just a positive presence. They play a crucial role in defining the identity of an atom. You see, each atom has a unique number of protons. This number, known as the atomic number, is like a fingerprint for the atom, setting it apart from its tablemates on the periodic table. For example, hydrogen has 1 proton, helium has 2, lithium has 3, and so on. This pattern continues throughout the entire periodic table. But protons do more than just define an atom's identity. They also contribute to its mass. Despite their small size, protons pack a punch, weighing nearly 2,000 times more than electrons. So, protons are like the unique identity card, determining what kind of atom we are dealing with. Next we have neutrons, the neutral particles sharing the nucleus with protons. Neutrons, as the name implies, are neutrally charged. They carry no electrical charge, unlike their positively charged proton neighbors and negatively charged electron counterparts. In the heart of an atom, neutrons and protons cohabit the nucleus, creating an interesting dynamic. You see, while all atoms of a certain element have the same number of protons, the number of neutrons can vary. This variation leads to the formation of what we call isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. They're like siblings, same family, but each with a unique identity. Neutrons also play a central role in the stability of an atom. Too few or too many neutrons can make an atom unstable, leading to radioactivity. So, while they may be neutral, neutrons are far from insignificant. Neutrons, though neutral, play a crucial role in the stability of an atom and creation of isotopes. Finally, we have electrons, the negatively charged particles whizzing around the nucleus at incredible speeds. Now, these speedy particles don't just zip around haphazardly. They're organized into energy levels, or shells, each with a maximum capacity. The closer the shell is to the nucleus, the lower its energy, and vice versa. But what's exciting about electrons is that they're the party animals of the atomic world. They love to interact, and these interactions, or bonding, determine the chemical behavior of an atom. When an atom has an electron that is free to move, it can participate in chemical reactions, forming bonds with other atoms. Think of electrons as social butterflies, flitting from atom to atom, creating a myriad of chemical reactions. Their movement and interactions result in the creation of everything around us, from the air we breathe to the water we drink. Electrons, small yet mighty, are the driving force behind an atom's chemical reactions. So, we've journeyed through the tiny yet complex world of an atom. We've met the positively charged protons, residing in the nucleus, which is the heart of the atom. They set the identity of an element, determining its place in the periodic table. Alongside them, we found the neutral neutrons, adding to the atom's mass but not its charge. They play a vital role in nuclear stability. Then, in the electron cloud, we encountered the negatively charged electrons, buzzing about in their energy levels. They're the architects of chemical reactions, forming bonds that create everything from water to DNA. Understanding the atomic structure, the protons, neutrons, and electrons, is fundamental to chemistry and physics. It's like learning the alphabet before writing an essay. This knowledge is our gateway to the microscopic universe that exists within every atom. Remember, every atom is a miniature universe in itself, and understanding them is the first step towards understanding the universe. Until next time, keep exploring.